All right, good morning, evening, whatever. I have no idea when you're watching this video, as long as you watch it by Monday and get all the stuff taken care of by Monday. I don't care. So hope you had a good weekend, or hope you have a good weekend, depending on when you get this. Let's get started here. So we're doing 312. Now, lesson 312, we're going to do the whole thing on video, which is good and bad. It's good because it's confusing. It's bad because it's confusing. The good thing about it is you can, if you get lost, you can always go back and watch it again. And some of you may need to watch this again. I am going to ask you to take your time. You are going to need to make sure that you go slowly, do the steps that I ask you to do, and walk through that whole process with me. Please no skipping. Please no just playing it on 1.5 speed. Yes, I know some of you do that. To get it over with. This is one of those lessons where I promise if you are not paying attention, good luck. Because it is confusing. We're going to be talking about zero and negative exponents. And so that can be really challenging. So please make sure you focus, okay? For today, you will need the review preview because we're going to go over that. You'll need a red pen, paper, and you might want your Chromebook if you cannot see the screen well. That's really up to you. I should have everything up here so you can see it okay, but it's up to you whether you want to pause it and go to your Chromebook and follow along with the online book if the exponents are an issue as far as seeing them, okay? All right, and of course, as you see here, your review preview, you are going to do it today. It's 19 through 24, so after we do the lesson, you're doing the entire lesson on video, okay? So I expect you to have the review preview in by tomorrow, and we'll be checking it in class tomorrow. And of course, I uploaded this, and it didn't give me my little bar to switch things over, so there we go, okay? All right, so let's go to the review preview. So here it kind of is. Oh, is it not? No, it's not plugged in. Oh, that's always fun. All right, hold on just a second. Okay, so my screen wasn't connected, so now it should be good. Okay, there is a review preview. Please pause the video. You're going to pause the video now, check all your homework. When you are done, please make sure you check with me if you have questions. Since you're doing all of this remotely, there is no opportunity for you to check unless you check with a neighbor or someone, a friend. But please take your time, find out your answers. When you are done, unpause it, and we'll come back together. Okay, so hopefully you checked your homework. Hopefully everything was good. We're going to go ahead and move on now. So you need a blank piece of paper. Please label it 312 for today's lesson. And let's get started with it. 312, how can I rewrite it? Zero and negative exponents. Ladies and gentlemen, exponents are not going away. That is something you are going to address, you're going to be working with throughout this year, throughout next year, throughout high school. If you do any math in college, you're going to be addressing exponents in college. It will not go away. You will see it on most tests this year, period. So this is something you really need to focus on. And if you do not understand what we're doing, you need to talk to me now so that I can help you out, okay? In lesson 311, you use the meaning of an exponent to rewrite expressions such as y to the fourth times y to the second and the quantity of x squared y to the third power. Today you will use the patterns you discovered to learn how to interpret expressions with exponents that are zero or negative or zero, okay? And so what I want to do first is I want to make sure that we address or review the skills that we talked about. So we talked about this yesterday, but just making sure you remember that you have to have these memorized, okay? X to the 25th times x to the 40 would be x to the 65. Why? Because we're multiplying exponents with the same base. We end up adding their exponents, okay? So that would be x to the m times x to the n would be x to the m plus n. If we were dividing exponents, okay, x to the 36 over x to the 13 becomes x to the 23rd. Because when we do this and we're dividing exponents, we end up what? We end up subtracting the exponents and getting that. And finally, the quantity of x to the 5th to the 12th power becomes x to the 60th, because when we have them in parentheses, we end up saying, hey, this quantity is being multiplied by itself that many times, and we can do that by multiplying. This becomes x times m2 times n. Okay, you have to have those memorized. You have to know how to do those. There is no shortcut. There is no way around it. You have to know it. So please memorize these and learn these, okay? Now, we're going to use this concept and these ideas for today's lesson. And here's today's problem. Problem 314. Describe everything you know about x to the m over x to the m. So please write 314 and write x to the m times over x to the m. What is its value? How can you rewrite it using a single exponent? What new conclusions can you draw? Be prepared to explain your findings. Forget the explaining. You're not explaining anything, but think about it. Now, here's where I want you to dig deeper. Some of you are going to find an answer right away. But if all you find is one answer, then you're not thinking deep enough. I want you to think deeply. In fact, I want you to pause this video. I want you to think about this for a minute. I want you to think, what is the value? How can you rewrite it using a single exponent? Everything you can. Think about it right now, and then unpause it when you think you have the purpose of this problem. Go. All right. Please tell me you put some serious thought into it. This is what I'm really challenging you to do in honors math, is to think deeper and not just the most obvious thing. However, you should have come to two conclusions, two of them. One is this: x to the power of m over x to the power of m. If they're the exact same thing, you can obviously figure out that this is a giant 1. So x to the m over x to the m equals 1, right? Hopefully all of you came to that conclusion. But there's something else that comes into play really quickly here, and it talks about the rules we just talked about here. Did you catch it? The rule is, when we are dividing exponents, we subtract their powers, their exponents. And so x to the m minus m, well, m minus m equals 0. So that would be x to the 0. So this, x to the m over x to the m equals 1, but it's based on the rules of exponents. We know it's x to the 0, meaning, and here's the big conclusion, x to the 0 equals 1. Always? No matter what? Well, that's what this seems to imply. So if I had, 5 to the 4th power over 5 to the 4th power, well, 5 to the 4th power, I'm not going to find it. That's a big number, but you could find it if you want to. But aren't they the exact same thing? So that equals 1, but the rules say 5 to the 4th minus 5 to the 4th would be 5 to the 0, meaning 5 to the power of 0 equals 1. Do you see that? Does that make sense? Okay, so whenever I'm dealing with that, something to the power of 0 equals 1. So that, hopefully you get that, okay? Write this down. Make sure you have that, okay? All right. Well, let's keep going. Problem 314 helped you recognize that x to the 0 equals 1. Now you will similarly use division to explore the meaning of x to the negative 1, x to the negative 2, etc. Simplify each of the expressions below twice. One by expanding and simplifying, and again by using your new pattern for division with exponents. I'm going to do some of these. You are going to do some of these. We're going to pause the video at some point, but we're going to walk through a series of problems. Now again, please remember what I said in class. You always start out by writing the original problem. So always write 315a and write the full problem, x to the 4th over x to the 5th. Okay? Now, first thing it said, you're going to first expand it. So this would be, and you do not need to put a dot in between. You can just put 5x's and 4x's, okay? Because the letter by letter means to multiply, all right? And you get that, and then you simplify it. Oh, this x and this x and this x and this x. All right, cool, I'm left with that. Oh, what is that? Well, I'm left with 1 over x. Okay, 1 over x, awesome. But now I call it the step number 1 is to do that. Step number 2 is to use the rules of exponents, which says x to the 4th divided by x to the 5th is the same as x to the 4th minus 5. Okay? So 4 minus 5 is negative 1. So x to the 4th equals, this equals x to the negative 1. Meaning my conclusion I can come up with is these two things are the same. So x to the negative 1 is equal to 1 over x. Cool? All right. Can you please try number 2, doing both ways? So, letter B. Do letter B right now. Write the original problem. Expand it first and simplify. And then the second way, follow the rules of what we just did. Okay? When you're done, unpause it. Okay, so you should have had that, and then again they cancel out, and you're left with 1 over x squared. But if I follow the rules of exponents, x to the 2 minus 4, that gives me x to the negative 2. Therefore, x to the negative 7th power is the same as 1 over x squared. Okay? Try letter C now. Now, hopefully you did this problem and you're like, man, okay, I get it that this is getting a little obnoxious, right? 1, 2, 3, 4, 5, 6, 7. Over 10 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yikes, ran out of room there. Okay, so cancel out, cancel out, cancel out, cancel out. Yes, I know this is obnoxious. I'm not asking you to do this for very long. Okay, but I do want you to do this. This would end up with 1 over x to the third. But then when I use the rules of exponents, 7 minus 10 equals x to the negative third. So therefore, again, x to the negative third is the same as 1 over x to the third. Are you catching on? Okay? All right. So that's a good trick I want you to learn. Now, I'm actually going to take a pause. I wasn't going to do this, but I'm going to go ahead and do this here, okay? I want to show you another pattern that we don't really do much, but the book doesn't actually necessarily tell you to do this, but it is a pattern that I think is really, really important, okay? So here's what I want you to do. This is just a side note here. Let's go 3, okay? Please, on your paper, please write 3 to the third power, 3 to the second power, 3 to the first power. Write that out, please. Okay? Right after it, right to the left of it, and this is going to take about 5 or 6 lines, 6 or 7 lines, so leave some space here, okay? 3 to the third power is what? Well, it's 3 times 3, which is 9 times 3, which is 27. 3 squared is 9. 3 to the first is 3. Please pause and analyze patterns. What patterns do you know here? Okay, what do you see? And again, we talk about math as a study of patterns. There are 2 patterns going on. Hopefully you recognize that the base is the same. The exponents are being subtracted. And what's happening to the answers here? We are dividing by 3 and dividing by 3. So, if we were to continue this pattern, the very next value below would be 3 to the power of 0. Okay, because we just subtracted. And if I continue the rules on this side, I divide by 3 again. 3 divided by 3 is 1. Oh, cool, check it out. 3 to the power of 0 is 1. That's another way to prove that anything to the power of 0 equals 1. But let's keep going with this pattern. What would the next value be? 3 to the negative 1. And over here, this is so cool. I love it. Divide by 3 again. Oh, well, 1 divided by 3. And if I go again, 3 to the negative second power, well, then I divide by 3 again, and 1/3 cut into thirds, okay, becomes 1/9, or 1 over 3 squared. Do you see that? And so if I did a 1 last time, 3 to the negative 3, that would be 1/27th, or 1 over 3 to the third power. Okay? So there is another way of proving how this pattern is working. Okay? And so you could do that with x. You could say all of these values, instead of the 3, you could have x. X to the third equals 27, and then have all these x. So over here, I guess it works better. X to the negative first is 1 over x. X to the negative second is 1 over x squared. Okay? So that's a pattern I want you to follow along. Okay? All right. So now is your chance to explore here. You're going to try some of this on your own now. Use your exponent patterns to rewrite each of the expressions below. For example, if the original expression has a negative exponent, then rewrite the expression so that it has no negative exponents, and vice versa. Also, if the expression contains multiplication or division, then use your exponent rules to simplify the expression. All right? So one rule of thumb. Never, ever, ever finish with a negative exponent. Now here, we are practicing some negatives, so there might be something where I leave it as a negative, I'll get to it. But in general, we never want to have a negative exponent, so this would not be finished. I always want to get it to where there is no negative exponent. So, write down 316a, k to the negative 5th, Now, I do not need to expand it. I didn't ask you to expand it. All right, k to the negative fifth ends up being 1 over k to the fifth. Ta-da, done. That's it. How about letter B, m to the power of 0? What is m to the power of 0? And by the way, please notice I'm not doing equal signs here. M to the power of 0 is 1. I guess if you wanted to do this and put it like that, you could. It's just, in general, we're going to try to work down, okay? I don't want this where you kind of keep going all the way off to the side and equals. For the future, in general, we're going to work down, okay? Letter C, write it down. X to the negative second times x to the fifth. And by the way, at any point, if I'm going too quickly and you need to pause, please do it. Now, this one is kind of the cool one. This one is pretty interesting because you can see this two different ways. You could say, well, x to the negative second, oh, that's the same as 1 over x to the second times x to the fifth. Well, then that becomes x to the fifth over x to the second. And then I use my rules of exponents, and I get x to the third because I subtract these, right? 5 minus 2 is 3. So that is one way you could do it. The other way, though, think about it. What's another way I could get that x to the negative second is the same as times x to the fifth is the same as x to the third? The rules of exponents say if I'm multiplying those exponents, I add the powers. And negative 2 plus 5 is the same as x to the third. So you don't have to do it this way if you don't want to, but one of these two ways should be shown. Either this rules of exponents here, or this rule of exponents here, but you should get x to the third, okay? And I just erased the answers instead of circling them, so let's put that there. X to the third, x to the third. And how about the letter D? 1 over p squared. Well, again, this is where it comes back to here. If the original expression, if the expression has an O and vice versa. So if it has a negative, get rid of it. If it doesn't have a negative, maybe you could do it. 1 over p to the second. In this case, and this is the exception of the rule, we don't usually do this, but that is the same as p to the negative second, okay? By the way, side note here, please make sure always when we're working with exponents, always, you cannot change them from a lowercase to an uppercase. Whatever the letter is must be used again the next time you do it, okay? So, this is pretty much it. I want you to take your time now, and I want you to work on solving these problems right here. I'm gonna have you pause the video and solve them and see if you get them right. Be careful, this is kind of tricky. I know that's a confusing thing where the problem with exponents is that they seem like they should be really easy and they come back and kick your butt. Okay, so take your time, write them down carefully. Please do not mess up with the writing, and then solve. Okay, so hopefully you did these. Hopefully you got the answers. This one's interesting, E. Now again, you can choose to do it however you want to do it. Some of them might have said, hey, if it's a negative exponent, I can put this on the bottom and this on the top. Wouldn't that take care of it? Well, let's see. At that point, I'd have y to the third over y to the second, and then I subtract those exponents, and I get y to the first. So let's see if that works a different way. So another way you could have done it is said, hey, I've got those exponents, and I've got the rules of exponents say subtract. So y to the negative second minus negative third, that becomes plus positive, and the answer, y to the first. So the correct answer for E is y to the first. This one, rules of exponents tell me if I've got them outside the parentheses, I multiply, so I get x to the negative sixth, but I don't want a negative exponent, so it becomes 1 over x to the sixth. Number 3. There are two, or letter G, there are two options you could do. One option is to go ahead and distribute, multiply those terms. So do a to the negative second and b to the negative first, and then switch them to a 1 over a squared b. That will give you an answer. That is one way you could do that. The second way you could do that is to say, hey, you know what? I'm going to put all of this, if it's the negative first, I'm going to go ahead and put it all as a denominator and change that to a positive. Okay, when I switch it to the bottom, it goes to positive, so there is to the first, and so there's my answer. Okay, And last but not least, 1 over x to the negative first, and maybe you've heard me hinting at it with letter E. This does not become 1 over x to the first, although technically, mathematically, that is correct. But if we want to focus on it, we could say the supergiant 1. We could say, hey, I want to get rid of the fraction at the denominator, so I go times x over 1 and times x over 1, because that's a supergiant 1. Remember those things? And these cancel out because they're reciprocals. I end up with 1 times x over 1, which when I multiply that gives me x over 1, or x to the first power. All right? So if I have a negative exponent, I can switch it to positive. Now that only changes the exponent, not the base, okay? So if this was negative 2, 1 over negative 2 to the negative fifth power, when I flip it to its reciprocal, when I go up here to the top, it still is negative 2, but it's the positive fifth. It only changes the exponent, not the sign of the base, okay? So please be careful with that. Whew. All right. That was that. That was today's lesson. And so there's a comic. You can pause it and read it if you want to. You need to do the review preview for today's lesson before you are done. And then please upload this picture by Monday night at midnight. I'm sorry, upload the review preview pictures and your note pictures by Monday at midnight, okay? So I don't necessarily care when you do it. Just make sure you get it done, okay? Don't do it at 11 o'clock at night. Hopefully not. If you need to rewatch the video, do it. If you have questions, write them down so you can ask them in class tomorrow, okay? I know this was long. Hopefully you stuck with me and we're able to get this done and it makes sense, okay? I will talk to you tomorrow or whenever you're watching. I'll talk to you on Tuesday, all right? Have a good day.